Hello everyone. Let us discuss about the calculation of limiting radius ratio. And this limiting radius ratio is very important in detecting the structure of the ionic crystals. Limiting radius ratio is the minimum allowable value for the ratio of ionic radii, that is R plus by R minus, for any ionic structure to be stable. For a particular coordination number, there is a limiting value of the ratio of the cation radius to the anion radius, that is R plus by R minus. Ionic structure becomes unstable if the value of R plus by R minus is smaller than that of the predicted value. So let us calculate the radius ratio, limiting radius ratio for various coordination numbers. So let us see for the planar trigonal lattice with the coordination number 3. Here the smaller positive cation of radius R plus is in contact with the 3 larger negative ions, that is the anion of radius R minus. So R minus, the radius of the anion R minus, and the radius of the cation, which is said to be R plus, the radius of the cation R plus. So let us take the equilateral triangle ABC. Use the trigonometric function in order to calculate the radius ratio R plus by R minus. So the triangle ABC, all the sides are equal. So AB will be equivalent to BC equal to AC, which is supposed to be 2R minus. So it is the summation of the radius of the two anions R minus and R minus. Then angle B will be equivalent to 60 degree. So all the angles are supposed to be 60. So angle equilateral 60. Then we need to calculate the radius ratio R plus by R minus. So we have to take into account the cation. So we just draw a line through B and touches the cation. Then you make a triangle. Then this becomes D and here it will be E. Now triangle DBE it will be BD will be the summation of the radius of the anion as well as the radius of the cation. BD, here is what? Anion. R minus plus R plus. Then comes BE, which is R minus. Now the angle B will be 60 by 2, which is the half of that will be 30. So here the angle will be 30. This is the one angle which is 30 degree. Now use the trigonometric function in order to calculate that. So cos 30 will be equivalent to adjacent by hypotenuse. So adjacent here is this one BE, adjacent to cos 30, and hypotenuse will be BD. B adjacent is BE and hypotenuse will be BD. So BE we know it is R minus and BD will be R minus plus R plus. Now cos 30, you find the value root 3 by 2, which is 0.866 will be equivalent to R minus plus R plus. You just take the reciprocal of this one, 1.0 divided by 0.866, R minus plus R plus divided by R minus. Then the reciprocal of this is 1.155 R. So this will be equivalent to 1 plus R plus by R minus. R plus by R minus will be equivalent to, you take this one this side, so 1.155 minus 1, and that should be equivalent to 0.155. Therefore, in this case, R plus by R minus is equal to 0.155 for the coordination number 3. So let us see for the tetrahedral lattice with the coordination number 4. We are just taking a cube in order to represent the arrangement. The anions are actually shown here shrunk for clarity at the corners of the cube, that is in the alternate position, and with the cation at the center. So the cation will be occupying the vacant site here. So the vacant site cation is occupied and will be coordinating with the anion. It will be in contact with the anion and is supposed to have a tetrahedral arrangement. So this is the one cation. So if we are labeling this part, this will be A, the cation site should be B, and this is C. This is what it is depicted below. So this is A, this will be B and C. The anion radius R minus, here it will be R minus, and the radius of anion R minus here, and this is the cation with the radius R plus. And the angle is supposed to be 109 degree 28 minutes since it is a tetrahedral arrangement. So let us see for the calculation angle ABC. What is that? 109 degree 28 minutes since it has a tetrahedral arrangement. Okay. Now angle ABD. So where is this D? Let us just label this point to be D, BD. So angle ABD. So this is the one. So here, this part, we are going to take angle ABD. Angle ABD should be calculated 109 degree 28 minutes, half of that. So it will be divided by 2. So, and that will be equivalent to what? 54 degree 44 minutes. How do you get that one? 109 degree 28 minutes. So this can be written as 108 degree. Then 1 degree is supposed to be 60 minutes. So I am just separating 1 degree to make it as a divisible one. So 1 degree will be equivalent to 60 minutes, and that is added again with the already existing minutes 28. So 108 degree, then 88 minutes. So now you just divide this by 2. It will be 54 degree 44 minutes. That is what here we have seen. Okay, so this is the angle value, we have got it. Now use the trigonometric function in order to calculate the radius ratio. So now let us take the triangle ABD. So here is the one. This is the triangle ABD we have taken. So let us see. In this case, we take the trigonometric function sine ABD. That is sine with the angle B. If we are taking, then it should be opposite divided by hypotenuse. What is the opposite? Opposite will be this one, AD. Then hypotenuse will be AB. So opposite will be AD and hypotenuse will be AB. So what is the value for what is the angle of B? It is sine 54 degree 44 minutes, and that will be equivalent to AD. What is AD? AD is R minus. This is the one, R minus. And what is AB? AB is the summation of R minus plus R plus. That is R minus plus R plus. Okay. Now you just evaluate this one. So it will be 0.8164, then R minus by R minus plus R plus. As usual, you take the reciprocal of this. So 1 divided by 0.8164 equal to r minus plus r plus divided by r minus. So what is the value of this is 1.225, and r this is supposed to be 1 plus r plus by r minus. Therefore, r plus by r minus will be equivalent to 1.225 minus 1, and that will be equivalent to 0.225. Therefore, r plus by r minus for the coordination number is 0.225. Hope you understood. Okay, let us see for octahedral lattice now with the coordination number 6. You could see a cross-sectional through this octahedral site is shown in this figure. A smaller positive ion of radius r plus touches actually 6 larger negative ions of radius r minus. Note here only 4 of the anions are shown in this section, and one is above this, and the another anion is below this one, below the plane of the paper, let us say. So here, how to calculate the radius ratio? You take this to be r minus and the radius of the anion r minus, and the radius of the cation, this is r plus. And here it is of a square planar. So here the angle is supposed to be 90. So in this angle will be 45 degree. The labeling we can do as A, this is B, and this will be C. Now you take the triangle A, B, T. In that triangle, we need to find out the angle of B, that is, D is supposed to be here 45 degree. Angle B is 45 degree. Then AB, it is r plus plus r minus, the radius of the anion as well as the radius of the cation, AB. And BD, what is that BD? BD is this one, r minus. Now the trigonometric function in this triangle ABD, you take that to be cos ABD. Cos ABD, then what is that cos ABD? Adjacent divided by hypotenuse. Adjacent divided by hypotenuse. This is the one adjacent and this is the one hypotenuse. So the angle is 45. Adjacent to that 45, which side? BD. Then the longer side will be the hypotenuse AB. So B, this is the adjacent divided by hypotenuse. Adjacent is supposed to be BD divided by hypotenuse is AB. What is BD? R minus. What is the hypotenuse? R minus plus R plus. Then cos angle B in ABD is cos 45 degree. Then that should be is equal to R minus divided by R minus plus R plus. What is cos 45? 0.7071. Then R minus plus R plus. Take the reciprocal of this one, 0.7071. 1 divided by 0.7071. Then R minus plus R plus divided by R minus. Reciprocal of this. The value of this is 1.414. Then 1 plus R plus by R minus. Therefore, R plus by R minus is equal to 1.414 minus 1, and the value is 0.414. Hence, for the coordination number 6, R plus by R minus will be equivalent to 0.414. Hope you have understood. Let us see for other things in the next part. Thank you.